Okay, so let me start over here. Let me try this again. We're doing notes. And our learning goal states, I can translate algebraic statements into word sentences. So now we're doing the reverse of what we did yesterday. Now we have to make up the stories. We have to set up the situation to represent the equation that is given to us. So it says, name the values that each variable will represent. So we're going to do just like we did yesterday. We'll say if we're picking the variables, well, this one they're picked for us, they're A and they're B. We're going to say, what does A represent in our story? What does B represent in our story? And then we'll write a situation that in our story that has that represented it along with the 12. Okay? So can anybody think of a couple of things we could add together and get 12? I don't want to know what numbers added together equal 12. I want to know what kinds of things could we add together and talk about as a story and get 12. Wait.
Foxes and raccoons, that's what I put.
Foxes and raccoons. Okay, so let A represent the number of foxes. Okay. And then B would be the number of raccoons. Does raccoons have one C or two?
Just one.
Two? One?
It's two.
One C, two O's.
Okay. I'm going to write it with both. I'm going to put two C's just to look at it. Raccoons. Okay, well anyway. So then, tell us something about your foxes and your raccoons.
So, in my word statement I put, there are 4 foxes running around in your backyard and 8 raccoons rummaging through your garbage. How many animals are there total?
Well, that's a very nice story. But we don't care about the 4 and the 8, okay? Because in other words, A and B can represent whatever in any situation. So we would say, if there are 4 foxes, then how many raccoons would there be? But so we're going to instead, let's think about what we were just doing with Amy is 5 years older than Bob. And so think of it like that. We don't really say in our story how old either of them are. We don't really say in our story how many foxes or raccoons there are. So we're going to stay with the foxes and raccoons. Okay, Harley? Okay, go ahead, Harley.
So I'll say there's 4 more foxes, but there's 4 times more foxes than
There are 4 times more foxes than there are raccoons. Okay, well remember, what did we say? What type of operation goes on typically when we say 4 times? Or multiplication. Is there any multiplication happening in this one? No, there's addition. Raccoon does have 2 C's and 2 O's, so we're going to leave it like I have it. Okay, so we're trying to get there. Foxes and raccoons. Anybody live out in the country? Yeah. And do you have like a field somewhere that you could say maybe there would be, you spotted so many foxes and raccoons? What could we say? Caden?
But there are 4 more foxes.
Where's there are 4 in this problem, you guys? There's an A, there's a B, and there's a 12. There's not a 4 there. I don't see a 4 there anywhere. Wade wanted there to be a 4, and I said no. Harley?
there are 12 more foxes in the field.
There are 12 more foxes than there are raccoons? Well, wait a minute. The equation says the number of A's, so A, the number of foxes plus the number of raccoons has to equal 12. Sylvia. Maybe if I quit looking at you and you quit trying to chew your gum, you'll be able to say it. Go ahead, honey. Can I let Sam try? Okay, Sam.
There are more foxes than raccoons in the field.
Well, so if there are more foxes than raccoons in the field, that would be okay, but what else do we have to make sure we include? The 12 has to be in there somehow. We're working really hard at this because we have to learn how to be good at this. So those of you who are not tuned in, oh, I feel so story for you when it comes time to have to produce this for me on a quiz and a test. Let's keep trying. The number of foxes, A, plus the number of raccoons, B, has to be 12. In the field behind Sam's house, start it that way, okay? In the field, behind Sam's house, she often sees foxes and raccoons. Oh, there's a good start to our story. In the field behind Sam's house, she often sees foxes and raccoons. Yesterday, what happened? She saw, she saw, right here. She saw a total of 12 yesterday. Of course, it could have been any day, but yesterday she saw a total of 12 foxes and raccoons. And that's all we gotta write. We don't have to even ask a question. That equation would represent, yesterday she saw A number of foxes, she saw B number of raccoons, and the total of them is 12. So then if she says to you, I saw 3 foxes yesterday, then you would be able to say how many raccoons she saw. How many raccoons did she see then? 9. Okay, so this is just, representing the situation, and then if we want to start asking questions, we can ask questions and apply those numbers to our situation, to our equation. Okay? Okay, do we have the thought process going down now, right? Are we ready to try the next one? 4 times C equals D. 4 times something equals something else. Fill out the word something. I'm like, what if? Go on forever. Somethings, there's so many somethings. Okay. 4 times something equals something else. Kira. What are going to be the somethings? The something and the something else's?
Grapes.
Bananas and grapes? Okay, well, bananas and grapes. We're going to do something with, do you want C to be the bananas and D to be the grapes, or vice versa?
Bananas be C, grapes be D.
Okay, so we can't just say bananas, because what about the bananas? You can't just say bananas. Are they green bananas, yellow bananas? Number of bananas, what is it?
Number of bananas.
Yeah, that would be good. Okay. Number of bananas, oopsie, that's it. Three.
Size number. Instead of 4.
Oh, they already have that there, that's right. If we were writing it, we would have to put the number of, sorry about that. Okay, and then the D is going to be the grapes. I'm so used to that we have to write out everything. And they've already done some of it for us. Okay, now let's do something with that equation and those number of bananas and number of grapes. Harley, you think you can do this? Okay.
There are 4 times more grapes than there are bananas.
Okay, so up there, use your own counter. There are 4 times as many, what was it, grapes or bananas?
4 times as many grapes than bananas.
4 times as many grapes as bananas on Kira's counter. Okay, that's enough. Don't forget it right. But I think we should check this one out, because these are tricky. Let's see if we have it. Let's see if we've written our wording right. Okay. So Pick some numbers of bananas or some numbers of grapes or something. Caden?
There's 5 bananas.
Okay, 5 bananas. Everybody do this with me over in the one of the sides, whichever side you want to do it on. There are 5 bananas, and remember the bananas are the C or the D?
C.
The C. So we have to put 4 times 5, that gives us D, the number of grapes. So 20 grapes, right? 4 times 5 is 20, you agree? Okay. There are 4 times as many grapes as bananas on Kira's counter. That's what it says. Is 20 4 times as many as 5?
Yes.
Good, then we got it. Good job. We need to check them out though, like this, because it's very easy that we could have turned it around and it should have been 4 times as many bananas as grapes. Who knows until you check it out. Okay, next one, our last one. We got an N and an M. We're taking 5 away from something and ending up with something else. You're giving 5 of something away and ending up with something else. I don't know. Help me out. Sam?
Horses and cows.
Horses and cows. Okay. Can horses be the N? Is that okay? Number of horses will be N, and the number of cows will be our M. Okay. Come up with the story for me now then. Horses and cows. So yeah. We lost it? Oh, okay. You can do it in the next 10 seconds?
Rose has 5 more cows. Wait. 5 more cows than horses.
Okay. Okay, let's try it. So, give me a number of cows or a number of horses, one or the other.
8 horses.
8 horses? Okay, so there are going to be 8 horses, and horses are our N value, so that would mean N take away 5 tells us how many M's there are, which are cows. What's 8 take away 5? 3. These are cows. So now we make the comparison and we see if it makes sense. His story says Rose has 5 more cows than horses. She has 3 cows, she has 8 horses. Is this 5 more cows than horses? No. So what should we do to change this up? What can we do to change it up? Katie?
Rose has 5 more horses than cows.
Yeah, let's just switch those 2 around. Just switch these 2 around. So it was cows before, now it's going to be 5 more horses than cows. 5 more horses than cows. So 5 more horses than cows. Remember, we picked a number of horses. We figured out how many cows there would be according to the equation. There are 3 cows. There are 8 horses. Does she have 5 more horses than she does cows right now? Then she does. Then our story is good. Okay. Think you can do this now? I was going to we're going to practice, but do you see what all you have to do though? You have to describe the variables that are represented in the equation. And you can't just, here they did this for us. I don't know if in your homework it'll do that or not. But you have to make sure that all of this is important. Let n represent, or you could say n is the number of horses. You don't have to use the word represent and all that. But you have to say number of horses. You can't just say horses. We could be talking about all kinds of different things with horses. We're talking about how many of them, okay? So get out some loose leaf.